So we continue our lecture. For an N-channel MOSFET, the source is connected to ground to turn the MOSFET on. We need to raise the voltage on the gate. To turn it off, we need to connect the gate to ground. So if the source is connected to ground, to turn on MOSFET, we need to raise the voltage on the gate. To turn it off, we need to connect the gate to ground. P-type, the source is connected to the power VCC. In order to allow current flow, the gate needs to be pulled to ground. To turn it off, the gate needs to be pulled to VCC. Depletion mode, it requires the gates of voltage applied to switch the device off. Enhancement, the transistor requires a gates of voltage to switch the device on. Despite the variety, the most commonly used type is N-channel enhancement mode. There are also logic level and normal MOSFET, but the only difference in the gate source potential level required to drive the MOSFET. How does it work in theory? I will try to explain it in the simplest way I can. For more details, or if you are in doubt, check the reference links provided at the bottom of the post. MOSFET is a voltage controlled field effect transistor that differs from a JFET. The gate electrode is electrically insulated from the main semiconductor by a thin layer of insulating material glass. This insulated metal gate is like a plate of capacitor which has an extremely high input resistance. Because of the isolation of gate, there is no current flow into the MOSFET from gate. When voltage is applied at the gate, it changes the width of drain source channel along with charge carrier flow electrons or holes. The wider the channel, the better the device conduct. The MOSFET are used differently compared to the infinite make MOSFET useful for power amplification. Power amplifier. The devices are also well suited to high speed switching application. So the input resistance make MOSFET used for power amplifiers. The devices are also well suited to high speed switching application. Some integrated circuits contain tiny MOSFET and are used in computers. Because the oxide layer is so thin, the MOSFET can be damaged by built-up electronic charges. In weak radio frequency work, MOSFET devices do not generally perform as well as other types of FET. Where to put the load to MOSFET source or drain? Because load has resistance, which is basically a resistor. For N-channel MOSFET, the reason we usually put the load at the drain side is because of source is usually connected to ground. If load is connected at the source side, the VGS will needs to be higher in order to switch the MOSFET. So there will be insufficient current flow between source and drain than expected. Typically, the heatsink on the back of metal oxide is connected to the drain. If you mount multiple MOSFET on a heatsink, they must be electrically isolated from the heatsink. It's good practice to isolate regardless in case the heatsink is bolted to a grounding frame. What is the body diode? For MOSFET also have an internal diode which may allow current to flow unintentionally. The body will also limit switching speed. You don't have to worry about it if you are operating under 1 MHz. Allow current to flow unintentionally. The body diode will also limit switching speed. You don't have to worry about if you're operating under 1 MHz. For technical resource and academic information about understanding modern power MOSFET. So, here we discuss some MOSFET. Now, MOSFET is used AC supply so we scroll this. Now we search is MOSFET used AC supply using voltage between two power supplies automatically switching between Williams system 9 power semiconductor. So we learned this. Everything is working very fine now. At first I use IRF 250 as my power MOSFET, one for each arm of the switch. When I tried using the 100 and 2 for each arm of the switch, the MOSFET burns out. I have repeated this and the MOSFET keep burning. Whenever I revert to using a single IF, the inverter works very fine. Relay switch circuit and relay switching circuit in practice, the SPD device such as diode, power MOSFETs, IGBT, BJT and thyristors. The typical switching frequencies lie in the range of 1 kHz to 1 MHz depending on the speed of semiconductor device. The switch network changes the DC component, the voltage, by Fourier analyze. The DC using power deliver 3 high power pure sine wave inverter circuit. The basic circuit of a boost converter. However, in this example, the switching transistor is power MOSFET. Both bipolar power transistor and MOSFET are used in power switching, the choice being determined by the current, voltage, switching speed and cost concentration. The rest of the components are the same as those used in the buck converter, as e-MOSFET are voltage operated device and consume no gate current. We can use a MOSFET relay switch circuit to control high power load, microcontroller relay switch circuit as well as digital logic gates. We can also use the output pins and channels for microcontroller PIC and process to control the outside world. The capability is an advance of developer designing USB power supplies for product that demand high power input to reduce charging time. USB powered semiconductor device. When the AC main supply is not available, an oscillator circuit inside the inverter produces a MOS drive signal. This MOS drive signal will be amplified by the driver session and sent to the output session. MOSFET or transistor are used for switching operation. These MOSFET or transistor are connected to the primary winding of the inverter transformer. When these working inverter with block conventional MOSFET require roughly 60. Under dynamic condition, the input are changing state and hence the transistor between the supply will either be both on or required energy to charge and discharge output capacitor. Hence the dynamic power dissipation will depend upon the number of times the transistor switch per second. The signal frequency rise. Online UP uninterruptible power Source that supply power from AC to main load via the inverter or rectifier combination. This UPS supply AC main power directly to the load. In online UPS, there is a continuous flow of current from the battery. Offline UPS only draws current from the battery during the primary power failure or power blockage. Online UPS needs a direct of under using internal timer of PSC mux amplified. So we use MOSFET amplifier circuit. MOSFET is a three-terminal semiconductor device used in a wide range of electronic circuits. It works like a JFET but has less current leakage. So we back this WD example plans. Sorry, words transistor. MOSFET common source. MOSFET common source state amplifier using MOSFET IRF 840. So resistor is connected gate to drain, source, capacitor and micro millifarad. Gate 1 is the headphone pin. Source drain gate is drain in gate source. Two sources short. So this is